All right, page 293 in your textbooks, numbers 11 and 15 for classwork. Take just a few minutes to work these two problems, and then we'll go over them together. Well, they don't have an answer in my book, so if you got this for 11, give me a thumbs up. Abby did.
I don't.
Oh no, Abby did.
Oh.
For number 11, did we get this answer?
Yes.
Okay, I'm getting a nod from Kendall as well, affirmative from Abby. We might have all been wrong together, but I doubt it. So we have reason to believe this is the correct answer. If you did not get that, check and see. Maybe we all made a similar mistake. Or maybe, yes, sir. Did you write something?
You added the, like in the first box, it says 2, 6, -1. You added the 2 and 4. That's supposed to be 8 there.
Oh, 2,
Yeah.
8, -1. Thank you.
Cause I didn't get that. Cause I got.
Do we like that better?
Yeah.
Okay. Let's go with that then. Kendall's like, yeah, that's what I had. Yeah, me too.
And
Uh-oh.
for the 10
it's
down there,
yeah.
it should be an 8.
Yeah.
-1, 0, 9. Oh, -1.
Mm-hmm.
Okay, there it is.
Yeah.
That's what Kendall had also.
No, that's what I got.
That's what I got.
All right, we like that better?
Yes.
Okay, all right.
The boys were right.
Ooh, all you girls suck.
Yeah.
I feel left out of the fraternity, though.
You're part of the boys team, I guess.
Okay, well, anyway. All right. She wanted a voice.
You can join a group.
All right, questions on 11 now that be careful, right? All right.
I was like, oh.
All right. Inverses. How do I tell if they're inverses, class?
That's a good question.
When you multiply. You multiply them together and see if you get an identity matrix. And then if you do, what do? Switch them and multiply again and see if it works out. So let's see if we come up with an identity matrix here. 2, 5. Well, that right there shoots the identity matrix. So class verdict is no. No, not inverses. That was pretty quick to get a no right there. All right, questions on the class work 11, 15. How many did better than I did? You got both of them right. All right, how many, like me, failed on the first one? All right, anyone fail on the second one? Questions at all on the second one? All right, next thing in your notes. Next thing in your notes. Using a matrix to represent a system of equations. Using a matrix to represent a system of equations. If I had a system of equations, let's just say something like a 3x minus 2y equals 5 and a 7x plus 8y equals, I don't know, negative 47. Well, you realize with the system, and I alluded to this earlier when we first introduced matrices, we solve for x and y, but the x and y really do nothing, right? Everything we do is with the numerical coefficients and the constants. We never actually use x and y for anything, but knowing what we're talking about. So you understand that if we stripped the x's and y's away, we could turn everything in front of the equal sign into something called a coefficient matrix by just keeping all the coefficients in their spots. Again, a matrix is simply an arrangement of numbers. These numbers are neatly lined up already by like terms. I could just keep the coefficients and forget about those x's and y's. I'm too lazy to write them. Similarly, I could do the same thing with these two constants. I could make what's called a constant matrix, which in this case is going to be, in almost every case, going to be a column matrix, 5, negative 47. And so I can take systems of equations and rewrite them using matrices, a coefficient matrix and a constant matrix. But we understand that these two matrices aren't independent of each other, rather they're all part of the same problem, right? They work together. So if we take the two of them and we put them together, there's a big fancy word for put things together, and the word is augment. How many of you have heard that term before? It's what you do in a research paper. You take your notes, right, all a bunch of note cards, and your first draft is pretty much all of your note cards in order with little transitions between them, and that's why it sounds so bad, and that's why you do a second draft and a third draft and a fourth draft and a fifth draft and a sixth draft to get it to sound good, right? But we're going to turn these two things together into what's called an augmented matrix, showing that the two of them work together. So we'll put our coefficients, our coefficient matrix, and we'll use just a single line to separate the values in the constant matrix. And we have what's called an augmented matrix. And if you look at it, it's like the equal sign has been replaced by a vertical line, and the x's and y's have been taken out, and we put it in little bracket thingies to make it a matrix. Seem relatively easy to represent a system. We could do this with systems of three unknowns as well. For instance, if I had like a 7x plus 2y minus 3z equals 4, and a 5x plus y minus z equals 12, and a negative 3x negative y positive, let's go with an 8z equals negative 25. Well, in this case, this system of three unknowns would just be a bigger augmented matrix. I would need to leave room for 3 columns of numbers and 3 rows of numbers, and of course a single column on the back end. What do you suppose I'd write, Brandon?
7, 2, negative 3, 4, 5, 1, negative 1, 12, negative 3, negative 1, 8, negative 25.
How many think in the same thing he said? Now turn to your textbooks, if you would, to page 286. So flip back just a few pages from where you were. Page 286. And you see how in the example problem at the bottom of the page, they took that system and broke it into 2 different matrices, the coefficient matrix and the constant matrix. And then on the next page, they put it all together into the augmented matrix. I'm lazy. So what I would do is what Brandon did. We can go straight to the augmented matrix. I don't got to write 2 separate matrices to see where this thing's going. So look at example B. Skip over the first 2 matrices they made. That's a waste of our time anyway. And of course, we see the augmented matrix. Now notice, in letter B's example, it's a 1, 1, negative 1, 3. Look at letter B. The second equation doesn't have an x. It just has 3y plus 9z. So it's 0, 3, 9, and then on the other side of the line, the 5. The next equation, they normally wouldn't write 2x plus minus z equals 2. Sorry, Abby. Normally, they would just do 2x minus z equals 2, right? Or in this case, 2, 0, negative 1, 2. Do we see what they did in that example? If there's a variable missing, it gets replaced with a 0 because, understandably, that's its coefficient. Questions on that? So, not blowing anyone's brain with this part. Good. Now, within an augmented matrix, we can do different things to the rows. Picture mathematicians years ago looking at these matrices and being like, ooh, numbers. I wonder what I can do with them. And so they just start, kind of like, a Rubik's Cube, just start turning pieces around and mixing and matching and stuff. Picture something like that, and you're like, ooh, matrix, I can do that with a matrix. And playing around with the numbers. There's different basic processes we can do to an augmented matrix that will allow us to solve the system without really solving the system. And we call these processes elementary row operations. That's the next thing in your notes. It's a big fancy name, but it's not particularly challenging. Elementary row operations. Elementary meaning basic. Row operations, meaning things you do to rows. So basic things we do to rows. Sound good? One elementary row operation within an augmented matrix, okay? Because an augmented matrix represents an equation or set of equations, rather, correct? If it's not an augmented matrix, it's just a standard matrix, you can't mess with it because the numbers have predefined spots. But these simply represent equations. Or elementary row operation number 1, or ERO1, would be you can switch two rows. First elementary row operation, I'm going to differ, by the way, from what the book has, so don't copy out of the book, copy in my notes, please. But the first one happens to be the same, is to switch two rows. So kind of like, thinking like Rubik's Cube or whatever, it's like, I don't really like this one here. I'd rather have it up here. Okay, then 5, 1, negative 1, 12 goes on top of the 7, 2, negative 3, 4. And I'll leave the negative 3, negative 1, 8, negative 25 where it is. I haven't changed the value of anything in the matrix by simply switching two rows. Does that make sense? Number 2, you can distribute or divide a row by a number. You could distribute or divide a row by a number. Now the grammar here is a little off, I get it. It's distribute a number to a row or divide a row by a number, but anyway, you can distribute or divide. Okay, distribute or divide. Be like, I don't really like my bottom row here. I wish everything were multiplied by 10. Done. Right? Just because we can do that in equations too, as long as we multiply everything by a number. Or if we happen to, if we happen to have a row, for instance, with something like a 15, negative 10, 20, 45. Right? If we happen to have a row like that somewhere in a matrix, like, you know what? I can take a 5 out of everything. Right? You can do that because you can do that in an equation. We can do that in an augmented matrix. Does that make sense? So again, not a difficult concept. Step number 3 is kind of an interesting one. Or number 3 is an interesting one. You can add and subtract rows. Right? Like when we solve systems of equations by the addition method, where we add rows together. We can add or subtract rows, but leave one intact. We can add or subtract rows, but leave one intact. Now this differs a little bit from actually solving systems, right? Because when you solve systems, once you've added the rows, you don't need the old row. Here in a matrix, we will. So if we're like, you know what? Let's come back to the original, because I just made those numbers big and nasty. I'm like, you know what? I really want to add these two rows together. Fine, you can, but one of the two rows needs to stay the same. And I don't know, Michael, which row do you want to leave? Row 2 or row 3?
Row 2.
Row 2. Okay, so we're going to keep the top row for now. We're going to also leave the middle row for now. But instead of our third row, we're going to make our third row be the sum of these two. Do y'all see that? So what would the sum of these two rows be, Maddie? Negative 13. And there we go, right? So this changes up the way it appears. But again, because you can add equations within a system, we can also do that here. We just have to leave one of the rows the way it had been. Does that make sense on number 3? Number 4 is going to sound a lot like what we did in systems of equations. And that is, remember we would, for instance, coming back to a basic one, we had something like 2x minus 3y equals 7 and 5x plus 5y equals 11, for instance. Okay, I'd love to divide that 5 out, but I can't. I'd look at these and say, well, I could cancel if I'd multiply the top by 5, bottom by 2, and change the signs. Or if I multiply top by 5, bottom by 3. You can multiply a row, then add, and keep one of the original. So number 4 is to multiply a row by a number, multiply a row by a number, comma, add or subtract with another row, comma, and leave one intact. Multiply a row by a number, comma, add to another row, comma, then leave one row intact. Multiply a row by a number, add with another row, but leave one row intact. And these elementary row operations give us the ability to solve systems of equations using matrices instead of the traditional method. Now, to be fair, the traditional method of solving systems, I didn't think was that hard. Right? When we were solving systems equations before, it wasn't that bad. Do we really need matrices to solve systems? No, probably not. Though when you get into, can you imagine 4 unknowns, 5 unknowns, 6 unknowns, 4, 5, 6 equations? That could get pretty nasty, right? Well, with this, with matrices, it allows you to solve more complex systems with a more reliable process. The process we're going to use is something called Gaussian Eliminations. There's the next section in your notes. Gaussian Elimination. Named after Carl Gauss. When you're smart and come up with stuff, you get to name stuff after yourself. I don't know of anything called Nadaski anything. I'm not famous yet. But Gaussian Elimination. There's a couple keys to Gaussian Elimination. Key number 1, and really the big key, is element A11, the very first element in the matrix, must equal 1. You've got to get a 1 in the first spot. That's the linchpin of everything else. Because once you get that 1, everything else becomes really easy and falls into place for you. After that, we want all zeros below the main diagonal. After that, we want all zeros below the main diagonal. I'm going to put this on the chalkboard so it shows up on the camera a little bit better here for us. And I'll have you copy down some of these steps here as we work this example problem through. Okay, so using a matrix to solve a system using Gaussian elimination, you see step number 1, this is the key step, is to make element A11 a 1. Go ahead in your notes, leave space to write the steps down, but also copy down the system that's on the board. It's a 3x plus y plus 4z equals 1 for those whose eyes are not as good. X plus 2y plus 2z equals 3. And x plus 4y plus 7z equals 2. Go ahead and copy down that system. I'm going to show you how we use Gaussian elimination to solve the system. Now, especially the first few times through, because I'll be stopping to explain and stopping to show, it's going to seem like this process takes forever. And your gut thought is going to be, it's a whole lot easier the other way. Once I don't have to talk it through anymore and you're able to just let your brain roll and the crazy mathematician inside you just play with numbers, some of you will get to the point where you feel like this is faster. Some of you will not, okay? But it's something that I want to show and that you have to know anyway. So here we go. Step number 1, remember, is to get element A11 to be a 1. Is it a 1? It's going to be a 3. If I make this system into an augmented matrix, it's not going to be a 3 right, or a 1 right here. It's a 3, right? 3, 1, 4, 1. 1, 2, 2, 3. 1, 4, 7, 2. Right? But remember, one of your most basic elementary row operations is you can switch any rows you want. Well, here it's got a 1. Basically, everybody's got a 1 except for the first one. So let's put one of these 2 rows into the first spot. And let's see here. Genesis, which row do you want to move to the top row so our first spot will be a 1? The second row. So we're just going to flip-flop these 2 rows. So now my top row is a 1, 2, 2, 3. My middle row is the 3, 1, 4, 1, and I've got the 1, 4, 7, 2 on the bottom. I flip-flop 2 rows. Step number 1 is done. I've got the 1 in the first spot. Questions on that? Step number 2, and really steps 2 and 3 are interchangeable, okay? So you may want to notate this in your notes, but these 2 steps really could be in either order. You need to make these 2 numbers, A21 and A31, zeros, using this 1 that you just got. Okay, so these 2 need to become zeros. Really, everything below the main diagonal needs to be zeros, and you see that little triangle of zeros here in the bottom corner. Right? So we need a 1 in the top spot, and I need a triangle of zeros. That's the goal. Once we make that happen, it's super easy to solve the system. Well, I could make this right here start with a 0 if I just added the inverse of these 2 rows, couldn't I? Remember, we can add rows together, correct? Or subtraction's adding the inverse. If I were to just momentarily change all the signs, and then add these 2 rows, I'd get a 0 in this bottom spot, wouldn't I? I'm going to keep the top row. Remember, we said when we add rows, we keep one of the rows intact. I'm keeping my top row intact. But I'm going to allow the bottom row to change and become the sum of 1 and -1 class, 4 and -2, 7 and -2, 2 and -3. And I'm also, for now, going to leave the middle row just like it is. Okay, so the first thing we did, we switched a couple rows. Next thing we did was we changed the signs on one row so we could add with another row to knock out and get a 0 here. Let me erase the stuff here so I can continue working. All right, so notice technically we did step 3 before step 2. But remember, those 2 steps are interchangeable. Why did I do the other one first? Because it was easier. Right? I could see a 1 and 1 canceling each other. Now I need to get rid of this. These 2 numbers had to become zeros. I've done this one, I haven't done this one. How could I knock out a 3? Well, what knocks out a 3 class? A -3. I need one of these numbers to become a -3 to counter this 3. Well, obviously that means I'm going to need to multiply my top row class by -3. Now, again, we're multiplying the -3 for the purposes of adding. But remember, we keep one row intact. So in just a moment, my top row is still going to be 1, 2, 2, 3. But for now, let's temporarily distribute the -3 and rewrite this top row. Class? And now let's add these values together.
0, -5, -2, -8.
And the bottom row for now is still a 0, 2, 5, -1. We have the 1, we got a 0, we got another 0, there's just one more value. Remember I said there have to be a triangle of zeros in the bottom corner. Now I need to make this number a 0. And the way you're going to make a 0 in this spot here is step 4, you're going to have to use these 2 rows together. It's tempting to say, ooh, couldn't I use the top row because it's got a 2? But then you're going to pair a 1 with a 0, which is going to give you a 1 again down here, and we just undid the process of the 0 that we needed earlier, right? So don't do that. Use these 2 rows. What numbers would these both have to be to knock each other out, class?
-10 and 10.
-10 and 10. So let's multiply the middle row by, and the bottom row by 5. Now, do I really want this middle row to be big? No, but remember, the multiplication is only for the purposes of knocking out a 0. We can keep a row intact. So I'm going to keep my top row intact, and I'm going to keep the next row intact. It's just my bottom row that's going to change. So temporarily, let's rewrite the middle row, Audrey. 2. We're distributing a 2. 2 times 0.
0, -10, -4,
And the bottom row, we're distributing the 5. Abby?
0, 10, 25, -5.
Again, we're only changing them for the purposes of adding. We've already kept this row intact, but now the sum is going to go in my bottom row of the matrix. What's the sum going to be here? Kendall?
0, 0, 21, -21.
And now I've achieved the goal. I've done steps 1 through 4. I've got a 1 in the top spot, and I've got a triangle of zeros under the main diagonal. Again, I did a lot of talking and showing, which makes it seem like it takes forever. But it's really just playing around with numbers, going for a particular pattern. Once you've gotten to this point, we're going to plug in a little z right here. Remember the z that we took out? We're going to put it back in just long enough to say, if there were a z and an equal sign, what would z equal, class? -1. Okay, well remember, there was a y here and there was a z here. But I'm going to make it a -1 because I already know what z is. -2 times -1?
Positive 2.
+2, move the +2 over as a, to get, and if -5y equals -10, what does y equal? So remember, this was an x, this was a y, but that's a 2, this is a z, but that's a -1. 2 times 2? 2 times -1?
-2.
4 and -2?
2.
Move the 2 over as a,
-2.
to get x equals 1. And there's my answer for the system. All done with matrices. Again, is this faster? Maybe for some of you it will be once you're able to work at your own speed and you've really got it down. Maybe for some of you, you'll never get to that point and it'll just be something, well, I'll labor through it. If nothing else, it teaches mental flexibility, right? And being able to see things and looking into things and figuring some things out. Let's do another one of these together. Page 289 now, if you would, please. And don't copy the system, copy the augmented matrix they give you. Don't copy the system at the bottom of the page in the example problem, but do copy their augmented matrix. If you copy the system, your first step would be to turn it into a matrix anyway, so let's be lazy. Again, it's not that we can't solve these systems by the old method, right? But for our purposes in this chapter, we're going to do it with matrices. The first key to solving this system, this augmented matrix for x, y, and z, is to do what, Genesis? Make this number a 1. Now, last time, remember, we did this by just changing out rows. We had a row that already had a 1, put that there. Is that an option this time, class? There's got to be another way to get a 1 then. Thoughts?
The inverse of the second row.
Okay, so if I temporarily change all the signs in the second row and simply add these top 2 rows together, my top row can start with a 1. What's my top row going to be now, Abby, if I do that?
1, -2, -7, and -2.
But remember, I only temporarily changed the signs on that second row. I want to keep the second row intact. And that's one of the key principles is you make changes, but then you can leave things intact. All right, step 1 is done. We've got a 1. My next key, and there's really 2 steps we could interchange, but I kind of need to get a couple of class zeros, good Maddie, to lead the next one. Now, either one can become a 0. How might I get one of these 2 guys to become a 0?
Change the signs in the bottom equation.
Okay, if we temporarily change the signs on the bottom, or better yet, we already changed the signs temporarily up here, didn't we? Erase your bottom row there, cross it out and extend your bracket down a little bit. I'm going to erase because it's not too hard for me at the chalkboard, but maybe just extend down and cross that row out. Let's add these together at the same time, because that'll give me a 0 here at least, right? What does my bottom row become, class?
0, -2, -9, -10.
-1, yeah, it's okay. I made my mistake earlier, so I'll forgive you. All right. So hey, that worked out really great. We used a -2 to get a 1 up here, and we used a -2 to get a 0 down here. All right, I also need a 0 here now. All right, this has to become a 0. What might I do to make that happen, Audrey? Through the,
Middle.
right here. Put a -2 right here. Well, that'll make this a negative 4, but that doesn't help me get a 0, does it? Michael, help.
I don't know.
I need something to cancel with a 2. What's the only thing that can cancel with a 2, class? Negative 2. So Audrey was really close. But I don't put the negative 2 through the middle, class. I put the negative 2 through the top. Because here, Audrey, if I put the negative 2 through the top, it's going to turn this into a negative 2. And that's going to allow it to cancel. So temporarily, again, you notice I keep using that word. Temporarily, we're going to change this top row and multiply negative 2 all the way through. Audrey, what do I get for my new temporary top row?
2, 4, 14, 6.
All right, and we're going to go ahead and add these two, and the sum is going to become my new middle row. But I like my top row, right? I'm not leaving my top row in its changed state, because I don't like that. Okay, I'm only multiplying the negative 2 long enough to add and cancel. What does my middle row become now, staying with Audrey?
0, 7, 13, 2.
Good. And my bottom row for now is still 0, negative 2, negative 1, negative 10. 3 of my 4 keys are done. I got the 1, I got a 0, I got another 0. Technically, I did them in the other order again, but I've got 2 zeros underneath the 1. The last thing that's got to happen, I've got to finish the triangle. This has got to become a 0. And again, it's so tempting to want to come up here and just change some signs, but if you do that, you're going to mess up the first value. You can't mess up the first value. So when we get down to it, once we get 1, 0, 0, we've got to use the bottom 2 equations to make the 0 happen, which means what numbers need to exist right here to produce a 0? Genesis? 14 and also, of course, negative 14, right? You were thinking positive and negative 14, I think. So that means we need to multiply what through the top, class? Just the 2, and through the bottom, just a 7, right? Now again, temporarily. Do I really want really big numbers in the middle? No. I don't want to mess with the top. I'm going to leave the top alone, and I'm going to actually keep the middle the same. But temporarily, I'm going to multiply a 2 through the middle. What does my middle row become when I multiply that 2 through? Maddie?
0, 14. 11, 19 times 2.
Correct.
30.
Yes.
And 20.
There we go. So 0, 14, 38, 20. And in the bottom row, we've got to multiply that 7 through, Maddie.
0, negative 14, negative 7, negative 7.
And we're going to add those 2 new rows together to produce my third row, which is going to have the double zeros in it. What is that third row now, Kendall?
0, 0, 31, and
Something's wrong.
yeah.
This must be 25, 32.
What happened? Sorry?
I haven't done.
Something multiplied wrong somewhere.
I have a 9 somewhere, a negative 9 somewhere.
You have a negative 9 somewhere. Okay, let's backtrack. I don't know, unless the book happens to have a solution in there where I can kind of follow what happened.
It does.
Yeah, but I don't know if we're on pace with them. No, they kept referring back to row 1. We did a row 2. Change the size. Did I copy it correct? Oh, no. This is a negative 4. Right in the beginning. Negative 4, which is why there was the negative 9 originally. Okay. So you were right all along. I corrected you and I said negative 1. I just copied it wrong. You were going off what you copied. I copied wrong. So in that case,
Negative 64.
this becomes a negative 60. Wow. And so 38 and negative 63, somebody?
Negative 25.
That's a negative 25. Okay. And then here, that does give us negative 50. Okay, I was about to say, something ain't right. It's not supposed to work out that weird. I know that. I don't know what the answer is, but I know it ain't that. Okay. Copy error. God, I hate that. Okay. We're good now. We're good now. Just make sure this was a negative 4, and therefore later became a negative 9. Therefore, temporarily negative 63 long enough to give us a negative 25. Now then, once you've got the 1 and the triangle of zeros, you go ahead and put in the z just long enough to figure out what z is, class? Positive 2. And then you put in the y and the z value, and we solve for the y. 2 times 19? 38. We subtract away the 38 to get negative 28, and we divide that by the 7 to get negative 4. Then we put the x, the y, or negative 4, and z, or 2, back in, and make that equation. Negative 2, negative 4, 8. 7 and 2, 8 and 14, 22. Move it over as a negative 22, and that gives us a negative 25, so x equals negative 25. Is that right?
Negative 7. That should be negative 7.
It's a negative 7, and Mom has to negative. Anyway, that does change things a lot. It's like, man, it's a really big number. All right? By the way, you know, things seem weird. They probably are. Okay, let's try this again. Negative 2 times negative 4 is 8, but negative 7 times 2, negative 14 and 8 gives,
6.
well, negative 6, but it does move over as a positive 6. Wait, that gives me a more normal little number. 3, yeah, that sounds a lot more like, I was like, I didn't remember a 25. All right, 3, negative 4, 2. Ends up being our answer. I don't know, maybe, just a thought, maybe it's easier to find mistakes, copy errors inevitably, in a matrix because the x, y's, and z's aren't in the way. I don't know. But man, those copy errors will get you. Questions on the process, though. We're starting to see the process. Again, it's just playing with numbers. Copying them accurately is always helpful. But playing with numbers to get a 1, 3 zeros, and then it's really easy algebra because you're plugging in for single variables, basically, in each step. Let's do one more of these together, and then we'll be done for today. Page 292. Page 292. So flip over another page. Let's do number 5 together. That can't be right. Oh, yeah. Okay, we're going to do 5, and then I believe we're solving it as well. All right, so number 5, write the augmented matrix. Number 5, just write the augmented matrix. I think actually we'll pass on solving this one because without an answer key, it'd be a real shame to screw that up. So I don't trust myself today. Not coming off a few mistakes already. What did you get for your augmented matrix? Michael?
3, 2, negative 1, 11, negative 1, negative 5, 1, 15, 4, 3, 2, 30.
Good, with that line going down before the back half of the numbers. Questions on that? How many have the same thing? Good. All right, let's do number 7 together then. Number 7. But don't write it down. Write it down as a matrix. And before we start, I'm going to have everyone make sure I copied it right. Is it copied correctly?
Yes.
All right, I'm getting nods. That's happy. All right. First step, class. Get a 1 in the first spot. Hey, done. All right, let's go to step 2. Get a 0 in one of these 2 spots. Let's just go with this spot. How would I make a 0? Thoughts? Top by negative 2. Only temporarily, of course, but let's put a negative 2 all the way through the top. Good. Now, really, I'm going to keep the 1, 1, 1, 3 because I like it, but temporarily putting a negative 2 just long enough to add and produce that 0. What's the second row now, Genesis?
0, 1, 3, negative 2.
Good. And you know, we need a 0 here, correct? What would I have to do to my top row, the original top row, to get a 0 here? Negative 3. Okay, so temporarily, what am I going to make my top row now here? Audrey?
3.
Okay, and let's go ahead and add these together to get my new bottom row, Audrey.
0, 0.
Ooh, careful. Okay, and now remember, once we've got 1, 0, 0 in the first column, we've got to pair the last two equations together to produce the 0 down here. What am I going to have to do to get a 0 down in that spot? Abby?
Multiply the middle row by 6.
Temporarily, middle row by 6 gives me what new middle row?
0, 6, -18, 12.
All right, so I'm going to keep the 1, 1, 1, 3. I'm actually going to keep the 0, 1, -3, -2. Temporarily, I've changed it though. Let's add together to get my new bottom row, Abby.
0, 0, -22, -22.
Okay, when I first saw that -22, I'm like, oh no, I did it again. No, we're good, we're good. All right, that looks like it's going to work out just fine. All right, we've got our 1 and triangle of zeros under. We're ready to go. Let's plug in the z. What do we get for z, class? 1. Let's plug in the 1 and a y. Multiply, move it across that equal sign. What do we get for y? Plug in the y and the z, which are both 1s, and the x, and what do we get for x? And so our answer happens to be 1, 1, 1. Don't you wish they were all that easy?
Yes.
Do we feel like we're starting to get the hang of how to use this process now? And do we see how once we're free of a lot of explanation, it really does go fairly quickly? Now, again, are they all going to be this easy? No. But I think if the more practice you get, you can get to the point where this is a faster process than what we had done before with solving systems of 3 unknowns. You're going to try just one of these in your homework this evening. So just one of these in the homework this evening. You have some other review homework as well. Page 294, do 2 through 12, the even. Page 294, do 2 through 12, the even. And then on page 292, do number 8. Page 292, do number 8. The number 8 is the matrix that we're solving, the augmented matrix we're solving. The others are just some review of basics. All right, we'll take a look at more of this tomorrow. This is, by the way, the last matrix concept. We're going to spend a couple days on it, make sure we've got it, and then we'll transition into a new chapter. We're not going to cover everything in chapter 6. Pretty much this fourth quarter, I've got 7 chapters to cover. I'm not covering all of it, obviously. What I'm going to do is I'm going to pick and choose the concepts I think are most beneficial and needful for you, and we'll cover just a kind of a smattering of topics throughout the quarter and go from there. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.